Okay, so this is going to be a video on the general power rule for derivatives. Um, we're no stranger to the power rule. The one we have before is the same as this one, but it didn't necessarily work for all instances of n. Uh, you weren't doing it wrong if you used it. It's just that the proof that I gave earlier is not one that necessarily covers everything, and this one does. So this is a general power rule. That's why it's called a general one, and it works for all power functions, no matter what the n is. Anyways, I'm just gonna go ahead and start here. So the derivative d over dx of n as of x to the n is equal to the derivative of e to the n l n of x. This n thing it's just equal to e to the ln of x to the nth power. I'm just using a logarithm property and just bringing that n back here. Um, but yeah, so that's where that n's coming from. I know known like NLN, that's not its own thing. That's just an n times the natural log of x. If that looked like it, I'm sorry. But anyways, now we're just going to say this is equal to, and we're going to use chain rule here, and we're just going to say e to the n. I'll make a little bit of space this time. L, that is an h, n ln of x times n, or well, the derivative of n ln of x, and that's going to be n over x because the derivative of the natural log of x is 1 over x, and n is pretty much just a constant here. So it's a constant times 1 over x, so it's n over x. And as we saw here, e to the n ln of x is just x to the n. It was just written in a different way. So it's that times n over x. And so this is just going to be, if we move this n out of the way, it's a little bit simpler. We could just say n times x to the n over x. And you can kind of see here how this would just be x to the n minus 1, because that's a property of exponents when you divide them like that. And then that n times this like that, right? So this is the same power rules we had before, nothing new. So I don't really need to give any example. I will just give like a quick one. But it's nothing new, it's nothing different. It's just something that you should know because you may need to prove it for whatever reason one day. So if I just say like 3x squared plus 5x minus 3, this is just going to be 6x plus 5 minus 0, right? So pretty easy, nothing new. It's just the power rule. It's just always good to know that I guess this proof for it. And in my opinion, it's just so much easier than the other one. And the other one didn't even cover all the possibilities. So I just really like this proof a lot more. If you weren't familiar with the derivative of the natural log of x, I just made a video about that if you want to learn about that a little bit. And then there's obviously plenty of resources on other videos of YouTube if you don't think I covered it adequately, or you can just tell me I didn't cover it, and I'll do my best to explain it to you, or I may make another video on it or whatever you need. I got nothing else to do. Snowed in. But yeah, so that's just going to do it for the power rule.